Okay, let's get started. Can you see my slides?
Yes.
Okay, thank you. That's great. So I gotta switch to the slides. Okay, hi everyone. Let's get started. And as mentioned, this is a make-up class, and we're gonna take this chance to review our assignment one, and at the same time, after that, we can discuss something about assignment two. And um, the purpose is that I hope you can be better prepared um, for assignment two and the project in the future. So let's get to assignment two first. In assignment two, we assign a task in which you need to um, conduct or train a model for sign language recognition. And actually, in our previous tutorial and lecture, we did provide you a paper rock scissors game, and that is tightly related to this task. And I see a lot of students made a good use of that toy program. At the same time, in the tutorial, we introduce a challenge from Cargo, and that's a sign language recognition task. And there are 26 signs there, and you're going to recognize it. Um, so the main challenge here is the cargo one is captured in an environment, in a controlled environment, so with perfect illumination, and those signs are with a lot of things aligned, like the hands are most like with the same size, and the background is quite clean or something like that. However, when you do it in a real world application, you might really recognize there are a lot of challenges addressed. The emulations are different, and background are different, and even different people are doing the sign in different way. So there are many challenges there, indeed. So here, let's get to start with some of the commonly adopted solutions, which are popular among the submissions. So first, for features, a lot of students has adopted LBP, 8 features, that what we have learned previously, introduced in the lecture. So those features are good. They are computationally friendly, but the problem is they are too sensitive to image noises and the illuminations. So I guess you really realize that. And the most importantly, as I put here, when we are introducing the LBP, it has been categorized into the global feature, meaning like they are considered the images as a whole, and it's a global feature, and it's actually histogram based, and so meaning like the the spatial information are not there. Like when you're using doing different sign, actually the background and foreground are quite similar to each other. It's all about the hand, right? And so the background wouldn't change that much. In that case, if you look at image as a whole without knowing the exact details or content, those images are almost the same because it's about the hand and background. In that case, LBP may not so good to distinguish from um, different signs. So, and for that reason, the LBP wouldn't work that well. This is some kind of disadvantage of LBP, but I'm not saying LBP is not good, because in this certain application, it just doesn't fit into their that that much. Um, However, if you really want to use LBP 8 features here, is it possible? Is there any solutions we can adopt? So there's actually no good and bad features. It's just about how you design it. So, if due to the time limitation, I'll propose something you might consider. So as I will introduce later, you a lot of students, they threw all the images, entire image into the learner. So meaning like the hands are just small part of it, something like here. Then actually they haven't done the hand detection before the training. So um, uh, this include a lot of background stuff there. So it will be good, and you can do hand um, detection first, and you just grab those small part of the hand there for recognition, and this will make it look more like this used by cargo. Oh, so that's another stuff I will talk about later. But here, let's get back to the question: can we use the LBP in this purpose? Yes, it's possible. You can try to like, you take this part out, it's a hand, then itself, it's an image. And right now, the LBP problem is like, you don't have the spatial information encoded in your feature, meaning they're describing the hand as a whole. However, if you can, we can do, this is a commonly adapted technique. You can use it in different way. Like you can actually use a grid to divide slice images into different patches there, and you will see that um, then for each of those patches, you can extract the LBP. So you will see probably this, because there are patches there. There's different patch will give you some information there about the details of different site. And because you know when uh, your user are doing different size, and they're supposed to be very different there. This is possible way. Maybe you can try it later. But if you're just taking the whole image to extract LBP, and you will have the problem as I mentioned here. There's no spatial information, and it's just, and the difference among different size, the difference among size are just minor. So LBP has such kind of disadvantage for this application. Okay, the second one is um uh you not students has considered to enhance robustness, use the hand landmarks rather than extract some features like LBP. Because in the paper, rock, scissors game, we actually use a very simple feature, which is the average of the interjoints distance. But at this time, we only have three classes. They are paper, rock, scissors. So that's why it's more than enough. But right now, this in this task we have 26 signs. In that case, it's not enough. So it's raised a lot of challenges there. So the best way is you can design based on the landmark. Design a different features based on that landmarks. Even you do succeed when I said some of students they just tried a few signs, but in case you have 26, that's original features in the paper rock scissors wouldn't work that well because it's just too simple. That's is the reason. So, and I guess, yeah, that's it. This is another company adopted solution, and appreciate it. You are thinking of it, and 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 this is quite different, actually, quite different from the LBP ages features or other features. Even some students are considering using the something like SIP feature, and there's landmark features because based on the assumption like the landmarks are accurate enough, and you can actually illuminate the um, the background, uh, the influence of the background, because you got the hand directly, you don't have to consider background, and you don't have to consider illumination. So assume the landmark is good. I guess some good features can be built. Actually, we did see some students have built good features on it, and they got quite good recognition there. So this is another commonly adopted models. Some students tried KNN, some students tried SVM, some students tried CNN. Um, so CNNs are a popular solution among the submissions as well. And because right now deep learning is quite popular, and suppose the convolutional neural network should give you state-of-the-art performance. However, even in recent weeks, we focus on deep learning, but deep learning stuff and has its own disadvantage. We didn't talk about it that much. That is, it's require heavy hyperparameter tuning, meaning like how many layers you need. And actually, some students raised that questions last time. So that's what I mentioned. If you're looking for a better some way of turning those hyper parameters, you can um, search or Google it, the AutoML. So these are some tools. This is a tool to help you to tune the hyperparameters. The hyperparameters meaning like, well, I'm sorry. And so the hyperparameters is like the number of layers and the number of channels or something like that. There are not um, parameters of your model, and it's hyper. That's why you got them hyper there. So, and most of the time, the engineers are just try different combinations and figure out what's the best. But this AutoML, they figure out some way to help you to fine tune it. So this is one. Another thing is, no, the CNN has a much more parameters, not only hyperparameters there than this traditional model, because you have to make sure those parameters are updated um, sufficiently. So meaning like those CNN relies on a large scale data sets. So that's most of the time. If you in the future, you probably will read more papers and articles there. You will see the state of art model. Um, consists of very large scale, like the Chat GPT. They got thousands of billion parameters already. That's pretty large compared back to traditional model like the SVM. So, meaning like large scale of parameters need large scale of data to train. Um, However, in case you just have a few examples, and not, it wouldn't work that well. So meaning like it's in certain scenario, its performance is not guaranteed to be better than the traditional models. In our this specific task, we're actually comparing back to the SVM. SVM is a traditional model which can take a few samples to train. So that's probably SVM that has advantages here. So I see some students tried Optim and SVM and saying, and I appreciate it. They have compared it and analyzed it. So I'm just trying to add more information here. Okay, there's another common solution aspect about models. And another thing I would like to take out some of the good examples there. So there is a good solution. There's not only one, there are several. And just due to space limitation, I can only just take one as an example. Um, so some features of the good solutions this time might be something like you have to use the hand detection to locate the hand position. Otherwise, it will be like the here if you don't do the hand detection, it will be the whole image feed into your neural networks or model. So you will see like there are a lot of stuff are not related to the sign. Will be the feature like those parts, like those faces and other places will be their feature will be extracted and combined into the features you want. I mean the hand. So in that case, you will confuse your model. You're confusing the learner. Well, which part they should focus. So that's reason it will be better. You can do hand detection before the feature extraction. And actually, in the tutorial, you will see what on the left is the dataset from the cargo. And you will see from the cargo the condition as it's controlled environment. So the background is clear and the hand is at the right position. If you don't do the hand detection, and that wouldn't work well. Even in a cargo, any model worked very well because that's just too perfect to be. And you could see this is actually this hand. It's right now looks very similar to the cargo result after the hand detection. And what makes in this specific example, he has done the background removal as well. So in case you're dealing with very complex background, this can remove the influence of the background. So these are quite useful technique there to improve the performance. And also, another feature is you have to use the real data sets for training and testing. Most students are doing that, but not all of them. And so I'll talk about it later. And, and robustness, or the testing of robustness is very necessary when you are really building an application. So the robustness means there might be different conditions your user uh, will face. compare back to the environment where you're building your application, because you probably just do it in your dormitory or lab, where the background affects, and that's just one. And illumination are more or less fixed as well. So, but in the future, when your users using it, they probably are doing it in a completely different environment there. Illumination matters a lot most of the cases. If you're using, especially you're using something like LBP, the illumination should be considered. And even you're using the deep neural networks, the illumination matters. If you haven't let your learners and exposed to different illumination, most of the time it wouldn't perform well. Um, because your learner hasn't seen that illumination, and at the same time, even you did the hand detection, the background sometimes matters, and it will be better you try it in different background, and that's another thing you try it. I mean, this should be done in both training and testing. You got to have samples with different illumination, and also it would be better you have it in different background, and also it will be good even you consider something like the doing it by different person, because different person doing the same sign different way. So these are quite important. And there's another thing I will introduce later called data argumentation. So these are something related. You can explore it. Data. Sorry. It's not easy to write. I mean, I just uh, using my hand to draw it on my touchpad. So argumentation, that's our data argumentation. It's quite related. It's quite related. So um and actually at very early age, like very early age, the neural when people are, I mean, before deep learning, people are using this technique, like they can randomly add some noise. They can randomly add some noise to the image. They can even blur it, rotate it to simulate the situation, like the your sample are taken from different environments. So this will help your learner to we're actually simulating the case that it's been exposed to different situations. So anyway, this helps a lot, and I will introduce more later. Okay. So, and you see here, and even some students have it tested by different person and different gender, and this one tested by male and female, and this one tested by different person. These are the same system tested by different person there. That's pretty good. So you will see that for the same sign, different people are doing it in different way. And so this is something I have to mention. It's quite useful for learning. So this is one. And there are also some solutions or not we don't recommend it, which has been tried by students, but that's okay because it's we're, as I mentioned, the point is to explore rather than any ends up with a perfect solution. So some students train it on the minutes. That is just what we have in the tutorial, and they use that model to test on real data, and for sure it wouldn't work well, and because there is domain gap, as I showed previously. The cargo one are captured in a perfectly controlled environment, but in the real application, I guess it really seen they're quite different. It's much more complex, and also test with clean background are very common, and so this is actually quite related to what I have mentioned in previous slides. It's not going to be robust. You just test it in one environment. It wouldn't work well if it will be used by different users. Okay. But anyway, I guess I hope this is a lesson to learn there. So and for the report, and so we did give you a very simple template, and also we gave you some sample report from last year by one of the students. So I see there are some good reports submitted in between. I would say that as mentioned, you can use any of the method which can describe your design, your experiment, your thought, or something like that. And these are some example I grabbed from one report. Um, he has used table to compare the performance there. It's quite obviously, and also you could see here he actually tried different classifiers, SVM, KNN, random forest, and other stuff there as well. And you could see uh, right here is quite interesting. The KNN actually perform very well here, right? So it depends on what kind of features you're using. Sometimes features and classifiers, they have been matched to each other uh, to get a better performance. And here you could see SVM and KNN are both traditional classifiers and work very well here. And also, um, I appreciate the second one is he has given a lot of examples there, and you can see we can you can you will know from the report much more intuitively what he's doing, what he has done, and the performance as well. So we encourage you in the future. You can give more examples, and sometimes we when you're doing experiment analysis, um, usually we include two parts. One is something like the overall performance summarization. Um, we call it quantitative analysis, and you gave evaluate quantitatively, and at the same time, you can use um, um, you can use examples to do more analysis or to figure out why it worked, why it doesn't work, or something like that. So, and this is a good example, and we encourage you to include that information in the future. And here's another one I grabbed from another report. I'll show you some examples of the report, and you will know what I'm saying. So this is another report. He has done a lot of visualization stuff for uh, to analyze the data sets and to illustrate the framework, and also this is actually the analyzation on landmark assets. So it's quite intuitive, and it will help you to figure out. Um, uh, this will intuitively test you how you can perform, because you see here the sign are well separated, and you have much higher chance to build uh, um, classifier with good performance. So I'll give more details when we're looking at that report. And here's another one. You could see, and she has actually put a lot of discussion there. This part is quite important. I mean, it's the priority is about how do you think about it, and discussion is one direct um, evidence about your thoughts. So you should put as much as possible discussion on it, your analysis and how it worked and how it doesn't work, something like that. And for the report, um, I there are some submission and they do got some problem like they actually they completely ignore the discussion and description part. They just provide some code. This is not a report, and and most importantly, we actually list some of the questions in the templates which you should answer. But this question hasn't been answered in that report. Um, so these are about reports and about the code, and you should improve to make the code. You should add more comments, and you that's are just basic programming stuff. But I and other submissions do not follow that very well. So I guess this part can be improved in the future. And also, user function are quite important. You can divide a problem into multiple sub problems in a manageable scale. So that's quite important. And these are basic programming stuff. So I wouldn't uh, elaborate more. So let's get into the part by looking at more examples of the report, and you probably get better idea and what I have mentioned. Okay, here's one report, um, and you could see she actually put it into well organized way. Uh, so do you actually see the report? Sorry, I forget to ask. Because I switched to the report right now.
Yeah, we see it.
Okay, okay, thank you. Okay, and here's the report. And she actually writes abstract, summarize the stuff she has done, and also she analyzed the data sets and analyzed the tools needed, their environment needed for experiment. And here is her analysis on the data sets. And this is original Minis data sets and lots of them. And also the framework she has used. And you know here you probably will see the accuracy here is not so it's not as much and comparable to the example I have shown in the slides, but it doesn't matter. It doesn't matter. So as mentioned, that's not a priority to get a good performance, and the priority should be given to your thoughts, your design, or something like that. And she does analyze the use of different classifiers like SVM, k-nearest neighbor stuff, and things like that. And there, so those part quite appreciated, and also she did mention some challenges there and gave examples are quite intuitive, and yeah, different challenges and also her solution. and her precision, data preparation, and some things like that. And anyway, you could see from here, you can grab a lot of information from her report before you actually run her program and read the code, and you really have a lot of information there. And so you could see here, experiments and feature extracted with very detailed analysis and the visualization as well. And finally, you could see here the performance has been improved. And so, okay, something like that. And okay, this is one, and I got another here as well. Here is another report, and they emphasize on different part, and you could see from here, and he has done some analysis as well, and also um, a, a screenshot of her program, and that's quite intuitive. And his experiment on feature selection has been reported there, and training and validation. And here is one, I think quite good. He specified his response to the question, and so and you know that his thoughts and which part quite can be related to the question, and it'll help us to read his report as well. And here model deployment and testing, and he actually have tested by different person. And oh yeah, you could see even for the same sign, there is some kind of difference from different person. And also discussion are quite important. And he has put discussion and a visualization as well. And I guess from this report, you do grab some kind of features, good features of the good report. Oh, and let's check out another last one. Here's another report from students, and basically he does done some analysis and describe his um, experimental setting in terms of models, data sets, and so on. And he has also tried, he has looked at loss, and this is one technique actually we have introduced to check out if your model is overfitted or underfitted, and that's is quite useful. And also this one I appreciated is he actually tried different thing, as especially describe her feature construction. He actually modified the paper rock scissors for his own use, so he developed different types of features are verified here, quite useful. And actually he has built a very good system there. I can yeah, actually he got that video from him, and let me put that out later. But let's look at his report, help you to understand something he has tried. And he actually tried a lot of features you could see here, a lot of things related to the feature as well, and identification of the problem, and background. The background influence has been investigated, and the problem has been addressed. And the size arrow, the color stuff, has investigated and tried by different person as well. And you could see people are doing it in different way, right? For the CMC, they're doing it in different way. So different person has different performance. And the other part is he actually tried the MediaPipe, which is another library for hand detection and landmark detection. And so I know some students are trying to use our services there, and they did make success. And he actually made it a success where our hand detection is a service. Sometimes it's not responds very well to your request, because might be at the same time a lot of people are using it. So he has tried this MediaPipe library, which can do the same thing but make the system more responsive there. So anyway, he tried different stuff. You could see even his report has been prepared with different style from very different from the previous two. But anyway, we don't have any preference on the style, and you can do it in your style as long as you put a discussion, put what they have tested. So that's will be fine. I will use those as examples to illustrate something related to the assignment one. And I can actually give you, as mentioned, you can look at his demonstration. Let me pull out the video. Hold on for a second. So, okay, let me find a video. Hold on for a second. I have to pull out that. Okay, here it is. Let me take that out. Okay, do you see the interfaces for the video?
No.
I haven't started, but do you see the user interfaces of his system?
I don't think we see your screen. We don't see your screen.
Oh, okay. You don't see anything, right, Marlo?
No, I don't see anything.
Okay, okay. Let me check out what happened there. I did share it. Okay. Okay.
Maybe we can move to another part.
Okay. So, you see it?
Yeah, we see it now.
Okay. Okay. Don't be shy, and it's okay. This is a system. Yeah. And she built a system and seems reliable. And okay, so this is the system. And just trying to give you some idea about system being built. Okay, I guess that's my comments about the assignment one. There are some more details, but due to time limitation, I wouldn't elaborate more. and we can discuss that in the future. So here, do you have some questions? We can take some question here.
I have a question, but it's kind of
Yeah.
a specific question to neural networks
Yeah.
and batch sizes. So when you're training the neural network, you have to input the models in batches,
Yeah.
and that creates a specific tensor size.
Yeah.
Let's say, for example, the batch was 32, so I have to input my batches of 32
Yeah.
of size 32 into my neural network. However, when I'm testing the model, um, usually I don't want to input necessarily 32 images at once, but do you have to input batches of 32 even when you're testing, or can you just input one image and get a prediction for that single image?
Yeah, sure. You could. So you're talking about testing, right?
Yeah.
Uh, for testing part, it's not necessary to use 32. You can just use one. The problem is you have to put you have to actually you have to modify the testing function. I mean, you have to adjust the shape or something, and you have to put them into I guess the problem is you have to modify your single example as a list when you feed you're feeding them into the model. So some students are actually feed trying I guess some student asking the question, they try to feed the samples from to the model directly. That wouldn't work. Actually from this let me recall. Actually we do have one example there where I feed one sample, but I put it as a list, or actually an numpy array, meaning like you are doing something like, let me use this one to illustrate. So I guess the problem you have is how to feed into that model. So usually we feed it like some list, like even it's numpy. So this is data of sample one, data of sample two. So this is structure we feed into that model for training, right? So so for testing, you got to feed it even a single example. If you, let's see, here is the data for your sample. If you feed it directly, and your model will they will think that this is a list, and the shape doesn't fit in that way. So what we usually do is we feed it in with this shape, then you can test it. So anyway, it's possible.
Okay, thank you.
Yeah, I guess you have to modify the shape.
Mhm.
And so if it doesn't work, just let me know later. Okay.
Okay, thank you.
Okay. So any other questions there? Okay. Most of the time, or like people are shy here for asking question. It would be better. Should you have any questions, let us know, and we can extend the discussion later on.
I have another question, if you don't
Okay,
mind.
sure. Yeah, sure.
When I was trying to test out like the real world application,
Yeah,
my computer is not very powerful, so the whole window was lagging.
yeah.
Do you know if we have access to computers with cameras in like a computer lab or something like that, so I can have more extensive testing without my computer dying?
Okay, so I guess the department does has the facilities. There's one lab in the sixth floor. They have some machines with GPU on it. I haven't used it, but I know there is one room with a GPU. Shilu, do you have any experience on it?
It's not using a GPU. It's just using the camera because I don't
Ah,
think it was
you
just using the camera and
okay.
the
Do you
estimation at
have
the
a
same
camera there? I mean, some kind of USB camera or something like that.
time. No.
Okay. The problem is camera, not the
Mind
GPU.
if I chime in for a second?
Yeah.
There are apps for Android at least that allow you to stream your camera feed over an HTTP connection, and
Mhm.
OpenCV will allow you to take an HTTP connection URL as a input.
Mhm.
There's also several pair per apps for Windows and Android, which will allow you to use your phone as a remote camera.
Mhm.
Oh, yeah, that's a
You can
good
always just fall
solution,
back to that.
actually. Yeah, that's a good solution. You can use your phone to stream HTTP, but it take more efforts, but I guess there are some apps can do it for you. Like there are some IP camera.
Mhm.
You can host the IP camera, use your cell phone, and there's an app for it. You can search over the IP camera. So it will stream your video, and it gives you an address and something like HTTP and IP and some kind of port of that. So when you are using, let me randomly get some code from here. So, okay, this code. So do you actually see my code here?
Yeah.
Yeah. So here is where we turn on a camera in OpenCV, right? So this actually can be used for open the HTTP camera, IP camera, or also such kind of stream. So you just have to simply modify this part by putting something I just mentioned. Once you have an IP camera, it should give you something like HTTP. Some kind of address or something, then give you a port or something like that. So this is one possible way. And sometime the app probably give you different types of stream. I have RDSP, STP, or RDSP. I'm not sure about anything like that. So you just have to replace this part here, and it will open up the string, and the same way like you're using a USB camera. Okay, thank you. This is a good suggestion and good solution as well in case you do stuck with the camera stuff. Yeah.
Thank you.
Yeah, I also have a question regarding more neural networks. Again, how would we do dynamic sizing for inputs?
Say it again. Analysis and
No,
inputs or
no, dynamic input size. Since
dynamic input size. Okay, you have to resize it. That's the only way possible right now.
no other way, right?
Yeah, yeah.
Because
You can
resizing is going
resize
to be quite
it.
wasteful, computationally speaking.
Because last students has asked the same question. Let me finish. So students has a concern after resizing the images, you got different ratio of it. So this is another part. It's okay to have different ratio as long as your learner has been exposed to that situation. You have that ratio. So if you during the training, you try different ratio and resize to them to fix the size, and your learner will be able to taking care of it. Like in facial recognition or face detection, they actually do the same, but there are different faces there that works equally well. So this is to say, the neural networks are actually looking at the faces in different way, like human beings are looking at it. We're kind of adaptive to the ratios or different sizes, but the neural networks may not. It's okay for it. Hope this answered your question. Seem like you added something there, right? So please continue.
No, I was just thinking of how to do it in terms of a programming sense.
Okay.
Yeah.
So you can taking the hand detection example. So after after the hand detection, you have this landmark recognized. So you can grab a rectangle based on that landmarks, and this rectangle have different sizes, right? So then you can use OpenCV. There's resize function we introduced previously. Usually a network requires an input like 128 by 128 or something. And then you can resize your image to that size. That's most of the time we're doing. So
Okay, thank you.
yeah, you're welcome. Any other questions there? Yeah, you see, your question may help others as well. So I do appreciate people asking questions there. If you don't have question, how about we take a break for 10 minutes and come back like 9:15. Then we can move on to assignment 2. I just wanna discuss a little bit before you're actually doing it. Even you actually see a lot of information which should be prepared for assignment 2. So that we can discuss it more specifically on assignment 2. Especially some students has missed the lecture, I guess. So will be better. Anyway, let's take a break for 10 minutes and come back at 9:15. Okay, let's just continue. Okay, let's just continue. Can you hear me actually?
Yeah.
Okay, thank you. Okay, so let's just continue and move to assignment 2. So maybe some students are not there. Let me briefly describe what we're going to do. So we're going to what we are going to do in assignment 2 is you are required to build some back-end model or algorithm which can support a campus tour app like what's shown here. So the way the user is going to use the app is they can hold their cell phone taking pictures when they are fooling around the campus, and your model should recognize what's inside that image in case what building it is, and give information like the name at building, office location, some other interesting stuff related like that. So this is quite straightforward. For building the model, it'll be something like you feed into an image and you got the information out as output. So this is what we're going to do there for the app, briefly introduce. So again, there are many possible solutions to build it, and the question is open-ended. And most important is to explore, is to try different methods and grab the experience back in case what should be considered when you're building an application in a real world scenario. So most students are doing quite well in assignment 1. I guess this is an simple extension in case you're really prepared by doing the assignment 1. I guess this is not that hard. Okay, so that's a task. And but I got a question from student like they think and can we build it as a retrieval system? Like you give an image, it can retrieve the images on file, and probably it matched to some of the images in their data sets. Yes, for sure. You can consider this is a image retrieval problem. In that case, I guess one of the challenges or toy examples we used previously would help. And so I'm just going to take this chance to review that toy a little bit because we let you know that challenges in toy, but we didn't even release the code, and I will release that code later on a Blackboard, and you will have it. But I'm going to take this chance to introduce it. So recall, this is a toy we used in lecture 5, and by given a video, and so I can't play that. So ignore that. I can't play it when because I'm using the remote desktop. But I guess you still remember this. You have a video, and we are assigning some. We are looking for some keyframes for that video. For example, we can take at the 20th as a keyframe, and every 20 frames, so you can consider it's a keyframe there. So last time we're just trying to verify if the BOBW worked for this. The way we're doing it is we assign each of keyframe a tone, and then for the other frames in between, non-keyframes, we're using BOW to extract the feature, and we can compare each of the non-keyframe feature to the features of the keyframes, and we can find the most similar one, and then we will take the corresponding tone. Like if it's matched to the 20th, and we will take the tone of the 20th to assign to this one. Actually, what we're doing is a combination. Every time we find two nearest neighbor, so theoretically speaking, for example, for non-keyframe in between the 0 and 20, its two nearest neighbor will be the 0 and 20. So we will use these two tones to combine a tone for this non-keyframe frame. Then in that case, if after all the non-keyframe tones have been assigned, when you're visualizing that image, you will see a gradual change of the tones. In that case, the keyframe matching or retrieval worked. Otherwise, you will see the jumping of the flips from here and the tones here and there, meaning that your keyframe retrieval doesn't work well. So that's the idea we introduced last time, and this is keyframe tone are given, and so nearest keyframe of query frame. The query frame right now is in between the keyframes. It could be here, here, and here. So you find the two nearest one and combine them regarding its distance to this two nearest neighbor, and you can use that weight to combine the tones of the keyframes. Okay, so yeah. Repeat this for all frames, and you will compose a new video. And that's what we have last time. So you can we can play it. No, we can't play through the remote desktop. I don't know why. Okay. Any question? Okay, so this is what we have, but last time we simply gave you a sample code for modified tone. So actually we got a lot of other tones. Oh, this is a typo there. So MP array. Okay, so I will share my implementation of this, but before that, let me explain what we actually I explain the code a little bit. I think if you're going to consider this is a retrieval problem, and this code will be used for in a way like you when you're doing the retrieval and you will face the situation, you probably need to index your image, especially when it's going to large scale, and you have to do the indexing as well. So here are implementation which will help you to use the idea of BOVW to index it. And so, and also it's a technology to convert multiple features into one feature. Because previously in the shift feature, we got a lot of key points for each of the frames. Each of the key points, they have its own feature. Then in that case, one image has multiple features, and you have to combine those features as one. Then you can compare between two images easily by evaluate the similarity or distance of their features. So this will be useful in case you have multiple features for one image. So let's see what it is here. So here you could see this is the one we use a lot by turn on or open the camera in CV2 and OpenCV. And we also have the sift extractor there. So here you could see we open the camera as a stream. Then so we could, through this loop, to get each of the frames from that video. And this time it may not be, it's not necessarily used for this part, because you can, it will be good. You can consider the regulation of information. I mean, if you can do it for video, meaning like you're when you're holding the camera, the video coming out, and the user will receive that information constantly, then and you could also use that. You could build the back end taking video as input, but it's not necessary. But this time, I guess you can just build one, taking one image as an input. But what's used mostly, the most useful stuff here is the way of constructing the BOVW, because you have to convert multiple features into one. That's more important. But let me, for completeness, I will introduce everything, because this is a toy we introduced previously, but we haven't explained it. So anyway, we open up the camera. Camera give us a video, and we take each frame from that video, and then for each of the frames, we do flip it, and also get the dimensions of that frame. Then we convert into the gray image, because for shift feature extraction, we don't need a color image. So just convert them into gray. Then we detect the features there, and you will get the key points and descriptors for each key point. Recall your knowledge of the shift. Every point has a key point, location, and scales, and at the same time, there is a feature vector associated to that key point. And then we flatten that feature and save it into a list. Then those are other stuff to response to the pricing of keys. So you should already be familiar with that. I comment a lot of things there. So this code is not neat. I hope some of the stuff I comment out can give you more clue about what, when I'm doing experiments and what I'm thinking about or something like that. So I haven't removed this part. It's not neat, but might be useful. So after you have the key point feature extracted, here you have to build a vocabulary, a code book, a dictionary. They are the same. They're the same stuff with different names. So we have to conduct vocabulary learning. In case here we actually already pulled up all the key points into the list. Oh, and so here you could see we're using the key means to do it, because in the TOVW stuff we actually are using, we're looking for one representative key point as a feature. Let's see if we have it here. Still have it here. Yeah, we still have it here. Remember what we have done for key points is we have the key points, and we can do the clustering and find the centroid from each of them to get as a representative as a code as well, and put them into the code book of vocabulary. So this is basically doing that part. Okay, we run the key means, then you got the result of the key means, and then you have the code book already, because you already have the classes. We're taking out the centers as the code. Then after that, you can build the, you can generate the BOVW features based on the vocabulary code book here. So you see there, we already have the centers already. The centers is the code book for us, because we're taking the centroid out from each cluster to construct code book. So the centers can be used directly as a code book. So here, for each of the image, because we have the feature saved already, so we can take it out. This DES is a feature of the key points. Then there is a very convenient VQ function will calculate its similarity to centers and assign it to certain centers there, like what we have introduced in the backwards here. So recall that. So after that, you will have the feature vector as a BOVW, BOVW. Then you return that BOVW feature to the caller. So here you could see basically this function has been called for you repeat that process for all the keyframes. Then you have one feature vector for each of the image prepared. Now it's getting to this part. It's corresponding to here. Like you already repeat that process. It's here. So you already have the keyframe, the frame feature extracted, and you can use that to compare them to the keyframe. The feature has been extracted, so we're going to assign them to the nearest keyframes, like we have mentioned here. And so let's get to this part right now. Here we are assigning, you could see here, I actually use a different way to do the assignments. And so here is the based on the similarity. So you can compare, here you could see, here's another loop. We're taking out the frame by frame, then we extract its key points and descriptors there, and we call that function to get a BOVW backwards, and for that frame, so it's a feature vector for that frame. Then here we are calculating its similarity. So we are not actually implemented it as a similarity. We actually are doing a doubt. So this is equivalent and to calculating the similarity, because it's basically calculating the inner product. Inner product is more or less the similarity. So you got a score for current frame, then you can compare, then you can sort, because this basically, this actually calculating the similarity of the current feature, the features of current frame for all we have as a keyframes, because from here we actually save the normalized features for all the keyframes here. So by calling this, you can actually calculate the similarity to keyframe once by calling this function. So in that case, let me get to here for better understanding. What we are exactly doing is you got the similarity of this frame, and you sorry, the BOVW features of this frame. Then you compare it to all the BOVW features of other keyframes. So you got a set of similarity, and which is here, it is shown here, which is the score is similarity. Then you sort that score to, then after sorting, you will have those keyframe with the greater similarity to current frame at the top. They will be top ranked, and ideally you will have this these two, 0 and 20 keyframes ranked at the top, and they are the two nearest keyframes in that case. And in case it doesn't work well, the other keyframes we might be keep top rank there. So, but anyway, this is to explain the correspondence between this code and that's kind of thoughts. Okay, after you rank it, and you can grab the top ranked keyframe from here. You can see that is here. So, and why we're doing this is we actually using this ranking. When you see here, we're actually get the first elements, because here we're sorting the similarity, but we're using ARG sort. ARG sort will give you an index rather than sorted scores. It gives the index of the scores. So by calling this rank 0, like you are getting the index of which keyframes, because here we actually, if you go here, you will see I already, okay, this is assignment of tones to keyframes. Actually calculate a gradual change of tones and assignment to, and assign them to each of the keyframe. So in meaning this is a list of tones. So here we are getting the top ranked ID of keyframes. Then we can take the tones from that tone list from here. Then we assign a start tone because that's the most similar and top ranked keyframe. We use its tone. It's like here. Because if this is the nearest one, and this tone will be assigned to here. If this is the one, this tone will be assigned to here. But right now we're picking the first start tone. So it's here, picking up the start tone. So we will use the second top rank. That's the reason you're taking the ranking 1. So you're taking out its tone to use as an end tone. Okay, it's here, it's the end tone, and if it's in between 0 and 20 and everything worked well. So then you can calculate a weight to combine these two. Then you have a tone combined using the start tone and the end tone. You could see it's just a linear weighting. We calculate the weight based on the similarity of the current frame to the nearest one. So we use that as a weight, a weighting scheme to combine the tone. Then current frame will have this tone assigned. Then we actually haven't modified it directly, rather we saved it into a list of tones, that this part, because we will do it later. So this tone assigned, then this is done. We save them into MPY file, and we can load it in the future for display. So, and in that case, I will go to the second program, which display the results based on the results you have here. Here, we actually already finished the assignment, but we don't even modify the tone. We just assign the tone. So for each of the keyframes and the non-keyframe frames. So, and then let's go to the second file. So here you could see it's repeat that process, but here we have the function I provided last time to modify the tone. So here we're just going to repeat that process of taking each frame out, extract it, taking each frame out and use the assigned tone in previous process to modify that. So this is quite simple right now. You could see we take each frame out. This is something you're quite familiar with. And you change the tone by calling that function directly, because you already have the tone assigned. The list, we actually taking out the list of tone from the file we saved. It's actually the file we saved here. You could see the file name. So we load that file into list again. Then because for each frame it has already been assigned the tones, so we can use that directly by calling this change tone function. And here, so you can see here while changing the tone. I'll explain this a little bit later, but here let's see the overall process. And then this frame, modified frame, will be shown, and there at the same time we write it back to a video as well. And this is a way for writing a new video. Actually, you have to generate a writer first, the code that provided, and you can just call this function to save that frame into a video. Then at the end, you will have a video rather than just display the result in a window. So this display part is quite simple. Let me elaborate a little bit here how we modify the tone. It's actually quite simple. You know, beside RGB way of storing the color for image, we can actually use the HSV system as well. So RGB is telling you the color composition, but HSV stands for the hue, the saturation, and the brightness. So this is HSV stand. These three stuff can define a color of a pixel as well. So there in OpenCV you can convert the RGB into HSV. So you got those three components for pixel. The advantage here is you can modify the hue because it's for defining the color. So you can because we already have the tone. Tone is defined by color, and so defined by hue as well. So we can modify the hue components and combine back to its original S and V components. Then you have a new stuff for each pixel, and you have a modified frame. This is where we're doing it. It's quite simple. And okay. This is the programs might be useful. As mentioned, you probably the most useful part might be how can you convert multiple features into one features. In that case, you can build a vocabulary, and then you can use the vocabulary by assigning each of the features you have into onto some of the codes in the vocabulary. Then based on that, you can calculate histogram to convert this assignment into a histogram. Then you will have a BOVW feature as one single feature for each of the images. So this part is quite useful. And in that case, this assignment part might be useful because you're calculating the similarity. But most important part is the vocabulary learning part. Okay. Okay, that's it. I think that might be useful in case you're going to consider it as as a retrieval problem. Even it's not necessarily a retrieval problem. Okay. Where is fine. Where is it?
It's in the Word doc.
Oh yeah, it's a Word doc. Yeah, right. Yeah, so getting that back. Yeah, thank you. So, and yeah, that's it. If in case you're considering it as image retrieval problem, and that might be useful. And but however, it's not necessarily a retrieval problem. You can consider it as a classification problem as well. In that case, every spot is a class, and you have to collect multiple images for one spot. So recall it back to what we just introduced in assignment 1. User might take, for example, the same building from different distance, different views, and different illumination conditions. Like they might take it at night, they might take it in the morning. So this will affect the illumination. Correct now, this time, everything is going to outdoor. I guess there are more components you have to taken care of. So, and also you probably should consider something, the size problem, resolution problem mentioned previously. And it's also possible to be considered as a classification problem as well. Yeah, this what I'm going to say for assignment 2, because you're just started doing it. In case you have some questions to ask, you can raise it here. So we can discuss a little bit. I'm not at this moment, I'm not going to give you a solution, but I can provide some kind of direction to organize your thoughts away or the way to figure out the solution. So is there any question or concerns for assignment 2?
Hello, Professor. I actually concerning about the data, the size of the data set. We, as you just mentioned that we should capture, let's say, multiple images for each buildings, and also in different times, and also and angles, and therefore for each buildings we may need to capture, let's say, many images for
yeah, that's
so
right.
Can we actually share some
yeah,
images to
it's okay.
others?
It's okay if for example you can pull up the data set into large scale by share the load with several the students. That will be fine. I'll say that will be fine. So you're actually talking about the scale of the data sets, right?
Yeah, and also above for the scope of this assignment, is that really necessary for us to recognize all the buildings, or we can just pick some?
It's the same like the question answer last time. It's not a priority to build it for all the buildings. So the most important part is to explore a different way of doing that, and also expose yourself and your model to different situations. That's most important part. And so the answer to that question is try your best efforts to build more, but it's not necessary to build for all of them.
Okay, thank you.
Yeah. So in case you have more buildings there, you should have more situation and to deal with. So, okay. Okay, that's a good question as well. Thank you.
Professor?
Yeah.
I wonder, like, can we do a neural network, like some image classification on the images instead of back and forth? Like,
yeah, sure. That's what I have mentioned. Yeah, you can consider it as a classification problem as well. And it's not necessary to consider it as an image retrieval problem, but you I will leave it for you to figure out the difference between these two. Both are possible. You just need to try it. They are different as well.
Okay, and I want to add something like when we're collecting the data set. So this is also what I did in my first assignment, is like taking a video on one specific building, and you can walk around to make sure there are different distance and angles, and then extract each frames from that like video as your data set. So I think it's a good solution. Like you can have thousands of images in just 10 minutes.
Yeah, that's that's possible, and that's a good way, maybe an efficient way to taking more pictures there. But so what I can what I want to say, there is limitation as well, but I will let you figure it out.
Okay, sure.
Yeah.
I think there will be some motion blur when we take
Yeah,
a video.
that could be one. Motion blurs stuff. That could be one. Yeah.
Okay, thank you.
Yeah, you're welcome.
Then I guess I also have a question. Are we expected to only identify the most prevalent landmark in the image? Or if there are, for example, multiple landmarks, are we expected to identify both? And if we're expected to only identify one, how would you determine what is the most prevalent? Just percentage of space taken up in the image?
Yeah, this is actually we are not expecting. You're talking about the perspective or the spot, the prevalence of spots, right? I guess you're talking.
No, I mean, if, let's say we have in one frame, we have two points which we have learned and which we can recognize, right? So pretty much I'm saying, are we doing image segmentation or image classification here?
Say it again, sorry.
Are we doing image segmentation or image classification here?
Oh, we are we didn't require you to fix we didn't fix it to any of the solution. So you can do whatever you have learned from that course. You can do segmentation as well. That's for sure. As mentioned previously, the possible solution are, you can consider it's a retrieval problem, classification problem, and you consider it a detection problem as well. So you can combine them. So these are all possible. It's open-ended.
Okay, so recognizing both the most prevalent landmark or multiple landmarks are both equally valid solutions.
Yeah, it's about how you construct your solution. So every solution are constructed, they are usually coming from some kind of thoughts. All the design features are coming from your concerns about how your user is going to use it. So you actually, for example, as I mentioned previously, your user is going to take that photo from different distances when you're taking the photo. This is one, they are going to take it at different time when you're taking the photo, right? So that's raised a lot of question. So your design are expected to address such kind of challenges as much as possible.
Okay, thank you.
Okay, sure. So yeah, those are all good questions, and I think it would be better to think in advance before heading into it. So see if there are any other questions there.
Are we supposed to go collect the data sets, like the pictures and the introductions on our own?
Oh, the introduction stuff, and it's not that serious. No, I think it would be better to accurate and fun. You basically can put anything. That's not a requirement to uh, to really you build something for the campus. So the text information is just additional information for different spots. You can prepare it in different way. You can put whatever you have. You can make it fun, and you can for you can make it very detailed, precise as well. For example, actually, there are some kind of introduction of each buildings you can grab from the website of the university. You can use that as well, but you can also use your own way to explain that spot as well. It's we don't have any requirement on that part.
Then the picture data sets, will those be provided, or we have to go to the campus and collect them at different times? Because it's mentioned earlier that the illuminations and angles will be different.
Yeah.
So
yeah,
we have to collect them our own.
Yeah, you have to collect it by your own. And one student actually proposed one way, like you can actually share the data sets. Like you can have one student taking care of one spot there. And then you put them together, you have much larger data sets there. That's a good idea.
Professor, I would
Yeah.
like to ask some questions about task 4. It's about implementing and testing a training model in real campus scenario. And is it okay that let's say I've collected a data set for, like, let's say the school entrance, about 10 photos like that, and I've only used 7 or 8 photos for training and reserved the 2 images for the testing purpose? It's okay for accomplishing the task, because it might be difficult for us to host the model and use our cell phone to really test it in the real campus scenario.
Yeah, understood. That is okay. That's actually okay. We also provide you some kind of pictures there. You're building a backend rather than a real application, a real app. That has been mentioned several times. And but you actually raised a new question. I guess students make consider it when you're doing assignment 2. That is, how do you split your training data sets and testing data sets? And you mentioned like you're using 3 of them for training and rest for testing. And this is a splitting scheme is something like 30% to 70%. And that's sometimes affect your performance as well. But I will leave that part for you to explore.
Oh, thank you, sir.
Okay, sure. So see any other question? Okay, if there's no other question, we already have reached the 10 p.m. already. So I guess that's it. And that's it, end of our makeup class today. And I do enjoy and appreciate your participation and enjoy the discussions we have. Anyway, let us know. Should you have any question, just let us know. But the best way, you can write your email to Liu Bo, because he's in charge of this assignment too. I guess you will have the response more quickly than from me in that case. So that's anyway, he's a best person to consult about the requirement assignment 2 and other thing like submission stuff or something like that. So that kind of question would be better go to him. But if you're trying to discuss some of the concerns of your solution, some kind of thoughts, some trying to get some suggestion, recommendation of the models or something like that. Those kind of questions you can find me, and so that's a way we provide information and answer questions. Okay, that's it. And feel free to find us to discuss after lectures and during the tutorials. Those are all good time for discussion. Okay, thank you very much and have a good night. Bye-bye.